All right, guys. So now we're moving on to volume, which volume is going to be that scale factor cubed, okay, to give us the relationship between the two volumes. So basically, in the first one, they tell if the dimensions, and when they say dimensions, that just means like length, width, height, slant height, whatever. So, and it can be any figure. Like I draw cubes if I got to get a picture in my head because that's the simplest one to draw, okay? So if the dimensions of a figure multiplied by 4, how many times larger will the volume be? So basically, if we're going from figure A to figure B, like the length, we're multiplying the length by 4, okay? So all we have to do is we take this 4. Oops. All right, so we take that 4 and we cube it, okay? Because our 4 is our A, okay? That's our scale factor. That's the difference between the sides, okay? So we do 4 cubed, that is 64. So how many times larger will the volume be? Well, it's going to be 64 times larger. All right, 64 times larger. So if we move to the next one here. So it says the volume of a figure is 110.5 feet cubed. If the dimensions are doubled, what will the volume of the new figure be? Okay. So what it tells us, it says the dimensions are doubled. Anytime they're talking about the dimensions, they're talking about our A value, our scale factor, okay? So our scale factor is being doubled, okay? So our A value here is going to be 2, because anytime we double something, we're multiplying it by 2. So the volume of this figure, it tells us is 110. We're going to use that here in a second, okay? So, and just thinking about this, if something is being doubled, all right, it means it's increasing. So the answer we get should be bigger than 110.5, okay? Because basically we're saying, hey, if one side is 2, the other side is 4, because the dimensions are doubled. So what's going to be the volume of the new figure? Well, volume, we have to take this 2, and we have to cube it. We're going to get 8. 8 is our A cubed value. So we are going to multiply the volume of that figure by 8, which is our A cubed value, and get the volume of the new figure. So we're going to take that 110.5 and multiply it by 8. And when we do that, that gives us 884 feet cubed. So that is the volume of the new figure. Like I said, since the dimensions are doubled, we know the volume is going to be greater. Is the volume greater? Yes, it is. Our answer makes sense. Okay, so now moving on to number 7. It tells you that the volume of a figure is 972 meters cubed. If the dimensions are multiplied by 2/3, what will the volume of the new figure be? So the dimensions are multiplied by 2/3. So one of the sides, if you take in that figure, you multiply by 2/3. Anytime we multiply by a fraction, we're going to get a smaller number, okay? So the volume of this figure is 972, meaning our answer is going to be less than 972, just so it makes sense. So we take that 2/3, all right, that's going to be our A value, that's going to be our scale factor is 2/3, okay? And we cube it. So basically we're saying 2 cubed over 3 cubed. When we do that, we get 8 over 27. Okay, 8 over 27. So all we have to do is now multiply that by the volume of the larger figure, which is 972. So we do 972 times 8 over 27. Make sure you put the 8 over 27 in parentheses in your calculator. And that is going to equal 288 meters cubed. Is the answer less than 972? Yes, it is. Okay. So that's the change in the volume. All right. Now, for problem number 8 here, it tells you it's kind of like the same one we did when we were finishing up the last one for the surface area. So it says solid A is similar to solid B. The volume of solid A is 21 inches cubed, and the volume of solid B is 4,536. How many times smaller is solid A than solid B? Okay, how many times smaller? So we're going to finish this one up on the next video, guys, and get this one all squared away for you.